I had a friend request some kind of basic tutorial videos, and this is a question that's come up a few times recently, and I thought maybe I'd attempt to hit it using this old CB radio. And the question is, my X is blowing the fuse and I don't know what's causing it, or my old TV is causing the rectifier to glow blue and melt down. I don't know what's causing it. And these short symptoms are diagnosed the same whether it's an old tube TV or a modern appliance or a vehicle or whatever. And really the only way to do it, if you don't know the pattern problems for that specific device, are to really get in there and get interactive with it. And that's what I'm gonna do with this as time permits. I'm not gonna go too hog wild on it, but we'll see where it gets. So whether it's a radio that's just blowing the fuse as soon as you connect the power, or a vehicle that keeps blowing the accessory fuse and you can't seem to figure out why, the method of diagnosis for that type of problem is pretty much the same. And in general, all electronic stuff, electrical stuff, is all laid out the same, whether it's house wiring or a radio or a vehicle or whatever. Doesn't matter what language it's in, doesn't matter what part of the world it's from. When you look at it, it's all the same. So this here is our fuse right here, and this is our positive, and this is our negative. This could be line, this could be neutral, and you have your loads here. Now let's say the problem is, the symptom is, it keeps blowing this fuse. Let's say it's a car. This is the accessory fuse here. Well, let's say this is the cigarette lighter, this is the dome light, let's say this is the trunk light here with the switch to turn the trunk light on and off. Let's say this is a defroster or whatever. You can first of all start by kind of logically ruling out certain things. For instance, the trunk light. The trunk light, you can check that by disconnecting the switch. The only real way to do this is to start disconnecting things in more of an automotive application or a house wiring type application. You want to start by checking the basics, like let's say for instance that's a cigarette lighter. Well, the first thing you want to check is to see, if someone stuck a dime in it, or something that's shorting it out. But the only real way, for sure way, is to check all these things individually, kind of visually, and then if that doesn't do it, you have to just start cutting wires almost. Let's say it's a tube radio, or this radio, because that would be the same. You have your fuse, or let's say this is the rectifier right here, and it's turning blue and burning up the rectifier tube. You can look at the schematic and you can see some of the loads are going to be direct. Like for instance, the filter capacitor would be direct. That could definitely do it. Or maybe the audio output transformer could have a direct path to ground. But in general, you're going to have resistors for a lot of the low consumption parts of the radio, like the IF, the audio preamp. The audio amp might have a direct, so you'd want to look at that. And this radio, the final transmitter transistor might have a direct path. So you can rule out pretty much right away the loads that have resistors. And you can rule out the loads that have switches that are disconnected when the thing is shorted. And I'll show you more what we mean on the schematic for this radio. Let's have a look at how shorted this is. Alright, well, measuring the resistance with the radio turned on, it's measuring about 87 ohms, which doesn't seem that bad to me. 87 ohms across 12 volts is going to be, what, a little over 100 milliamps or so. Maybe 150 milliamps. That doesn't seem that excessive, especially since it has dial light bulbs in it that the resistance goes way down when the filament's cold. So if we turn it off, okay, but yet it's blowing a 5 amp fuse, so that this does not mathematically calculate right now. Okay, now there's a much cruder kind of third world method that I didn't mention. Of course, the proper way is to go through and disconnect these one at a time till you find the load. The cruder way is to bypass the fuse and quickly apply power and see which one gets warm, or just bypass the fuse and see which one explodes into flames. That works too. But you really don't want to do that unless you have nothing left to lose and are just completely out of options. Sometimes you get carbon tracking or something in the circuit board and you just can't find it, and you just almost have to let it burn and smoke so you can locate it. So what I'm going to do is I'm going to, since this situation doesn't mathematically compute, I'm going to measure the current draw here, and I'm just going to touch this on real quick. And it's kind of interesting that it started out at 4 amps and then it quickly kind of dropped down to 3 amps on the second try. When you see that you generally would think of a capacitor doing that, but I can't see a capacitor being that shorted in this unless it's a tantalum. And this is interesting. So in this case, what I'm doing is I pulled the thing open, and I will have to say that electrolytic does feel warm. And these electrolytics, this style of electrolytics, these things suck. It had pulled off right there. Maybe this thing will pop. That would be kind of cool. It's slightly warm. Now it's actually getting rather hot. When I key it down, it's getting really hot now. And I don't have safety glasses on. I'm not really cool with this. Look what it's done. It's dropped down to 300 milliamps. There's still no output from the radio though. Okay, I think it needs to be recapped. And look at what the voltage has dropped down, the current draw has dropped down to, from 4 amps down to 170 milliamps. And this capacitor is cooking hot. So this is kind of a rare issue for a piece of solid state gear. Usually you don't see capacitors do this, but they do it in tube gear quite a bit. See if we could get the audio to work. Actually, let me put the RF meter on it, see if it's transmitting anything. Yeah, let's take a look and see if the transmitter is working. Yeah. Hello. Hello. 1, 2, 3, 4. Looks like it's moving a little bit. I could find it here. Hello, 1, 2. Hello, hello. Hello, hello, hello. 1, 2. Kind of working. One, two, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2, 2, 2, 2, 2. It's not real good for it to run it without a antenna on it, but who cares? I'm not going to, probably not going to use it. So it'd be interesting to figure out, it's got obviously the audio sections, the audio stage is working because the mic feeds into the very front of the audio stage. So if well, take a look at the schematic. Right, so this is kind of what I was talking about the power supply. You have the power coming in here, and then this is where it branches off here. So you could see this would be, whatever this connects to would be your direct feeds that would most likely cause a short. And of course there's the capacitor right there that was causing the problem. And then you can look at here, this is the relay, so this is hot and receive and this is hot and transmit. Well, you would automatically know that it wouldn't be anything connected to this, and you could pull this relay out, which would totally eliminate this. And then for instance here you have a resistor. Well, you know that if it's drawing 5 amps and that's a 400 ohm resistor, it's not possible. So unless the resistor is shorted, so you could eliminate this. So, and again here you have a 62 ohm resistor, which you're not really going to get 5 amps through without this burning up. So with the relay eliminated, you can eliminate all but just this line without touching any of this stuff. Let's take a look at how this thing is designed here. very complicated. So of course this is the where they call that an AF amp and a squelch amp. So this is the audio stage here. That's the audio amp, then the driver, then the output transistors. I'm not going to try and figure all this out, but the mic feeds into here, and then this would be the IF out right here. It's got a detector. Actually, it's got a very fancy detector stage. Okay, here's the mic right here. Here's the mic. So the mic comes up to the relay here. So here's the volume, and we know we have static when we turn the volume control. So when it's in transmit, the mic is connected to the audio amp, and when it's in receive, it's connected here through the volume control to the detector output. So the volume control has activity, so I guess it's possible that this capacitor could be wide open. We know it needs to be completely recapped. I'm not arguing that. I'm just simply saying let's diagnose it and figure out, oh, you know what would make short work of this? A signal tracer. That's all we need is a signal tracer. You just start right at the output of this IF transformer. Alright, well, here's the final IF transformer right here. It's the adjustment hole from the bottom. There's the one before it and the one before it there. So let's just see what we get here. Okay, my ears are ringing now. Let's turn this down a little bit. Just give it a little antenna there. I know that's not really the greatest thing in the world, but man, that thing is loud. Doesn't that sound good? Don't you wish broadcast sounded like that? Huh. I can't really get to that center point on the volume control from here. Or can I? Looks like it's wired. Is this it right here? Let's see. Is this it? Huh. Yeah, it's there a little bit. It's got to be that capacitor is open. It's got to be. Well, that capacitor, this is the center of the volume controls right here. And the level of noise is the same on both sides when the guy was talking. Let me see if I...
I heard somebody coming back. They're bringing my...
So it's obviously not that capacitor. Now we got another capacitor in here that was going to ground, which could be shorted. Let's see, this capacitor's, I mean, I'm not going to say it's good, but there's audio on both sides of it. There's this capacitor right here, because we got really stout signal on these two, and I don't know about on the other side of this detector, but what would this do if this capacitor was shorted to ground? That's a good question. Maybe I should check on the other side of this diode. Actually getting some signal out of here when they're talking, if that's what they're doing. So it seems like it works. It just needs a recap. This cap is completely cooled off now. I guess it's reformed. It doesn't look like it has that many caps. It looks it's got 1, 2, 3, 4, 5. Doesn't look like it has that many caps. Okay, smoked sausages with the skin peeled back. Now this thing is waking up all on its own. I haven't touched it. I've just been letting it sit here and run, and it's just waking up. So this is bad capacitors. And I don't even have an antenna on it. All I have is that screwdriver. All I did was I sprayed some control cleaner on this thing. Yeah, this is crystal controlled. So what channels do we have? 27475, channel 20, channel 16, channel 10, channel 8, channel... I need magnifying glass. The speaker was falling apart. The little cardboard ring on top had come off and the cone was coming unglued from the frame, so I glued that back together with speaker glue, and I'm letting it set up and dry. I'm really not going to do a total recap on this. It's not something I'm going to use. I might take it on a trip and just do some comparative testing with VHF and UHF radios. Make a video on that just to kind of see what works in what conditions. I did go through and I pulled all of these capacitors out here that are in the audio circuit, and I found one that was wide open, which is right there. You can see that new one, and that was a emitter. I want to say a cathode, but it's like a collector bypass cap, because this is PNP germanium. I checked all of the rest of them, and they were actually okay. And when I say okay, they weren't that leaky, and they weren't insufficient. If anything, they were overvalue. Just not going to spend a lot of time on it because it's not something I'm going to use. If we take a look at it, this thing is 100% American made almost, and I don't just mean assembled in the United States. If you just look at the components, these are all American sourced components. So I'll let that dry for a while. I'll put the camera on the charger, and then we'll come back and we will fire it up. Well, you can hear the difference with no antenna connected just by replacing that capacitor, and since that capacitor was in the audio circuit, it should increase the mic gain and modulation that much too. Nice, isn't it? Try a different channel. One, two. Oh wow, look at the difference there. Hello. 1, 2, that's a lot of gain. 1, 2. The thing with CB radio is everybody is so modulated and overdriven and out of control, you can't tell if the thing's working right. How would you even know if there was a bad transistor in it? It just sounds like trash no matter if the radio's working right or not.